So as we wrap up our journey into the introduction of electromagnetics, I'd just like to wrap up with we'll call it the places you'll go lecture. But the non-Dr. Seuss, non-rhyming edition. So where can you go now that you have this basic fundamentals of electromagnetics? Well, so the electromagnetics discipline, it can extend into a number of different subtopics. So here I'll do an incomplete listing. So the most straightforward one would be RF engineering, where you'd be looking at different applications of using electromagnetic waves specifically in the radio frequency to perform a variety of functions. Similarly, you can also do antenna engineering if you really wanted to focus specifically on the aperture side of things. So these, the widgets and the antennas and the rays that get the waves out there into space. Now separately, there's also a lot of people that work in the optics and photonics area. So note that that light is also an electromagnetic wave. It's just an electromagnetic wave at a vastly different frequency. So at a higher frequency, you get into the field of optics and photonics, where we use light to do different applications, communications, sensing. That's a whole area of research. Photonics is basically the electronics version. The is the optical version of electronics. So that is a different area to go into. Quite often, Maxwell's equations is Maxwell's equations, but with optics and photonics, because of the frequency that you're working at, once you're in the optical regime, you have a different set of approximations that take place. So the math is different, the intuition is a little bit different. Now, if you go down in frequency, a lot of the things that you learn here also apply to power electronics and power systems, specifically on the transmission side, on the utility scale, how you get energy from one side to another. And as we learned, if you're transmitting over long distances, you also run into situations where transmission line effects come in. Separately, a lot of the time domain work that we talk about also comes into effect when you're studying high-speed circuits or high-speed chip design. So this is where, once you get to the point, which is where many of the cutting edge devices are now, where you can't just treat signals in simple form. You have to worry about the way the pulses distort and how to take into account transmission line effects when you're designing circuits, and kind of, in my view, protect the digital people from the non-idealities of the cruel physical world. That is also a separate area where a lot of the concepts that you learned will come into play. And then more broadly, you can use electromagnetic waves to serve a number of purposes in biomedical as well as sensing applications. So this isn't specifically related to any of these in particular. It could also be a combination of these, but using these physics, you can also perform a number of applications, again, both in sensing as well as biomedical applications. And then finally, this is for those of you that really, really like multidisciplinary physics. Another really challenging area where electromagnetics comes in, and I didn't learn about later, is plasma science. So if you really want to just solve all our energy problems and create fusion, this is one area you would go into, but even absence of fusion, just nuclear science in general. And if you really enjoy physics, plasma science is a highly interdisciplinary, challenging area where you combine what we learn in electromagnetics, but add a lot of other areas of physics in, because plasma is the study of charged particles moving along. So you have to worry about the dynamics of a bunch of particles. So there's fluidics that goes along with your understanding of electromagnetics. And so the equations get hairy really fast, and the research also gets really challenging really fast. And one of the things that I'd also like to point out is quite often a lot of people that I know have success combining their knowledge of electromagnetics with other disciplines. So, for example, electromagnetics or RF engineering with signal processing, or electromagnetics with the life sciences for your biomedical sensing applications, or if you're looking at solid state devices and small devices that deal with electromagnetics, so RF devices or novel photonic devices. These also combine what you learn in electromagnetics with solid state physics. And I think that a lot of creativity as an engineer really comes from the intersection of these disciplines. And like in my case, I don't find myself the smartest person in the room, but a lot of times I find out that I have something to contribute, most notably because after working in a number of different fields, there might be something that's obvious only to me because I'm in the center of some really scattered Venn diagram of a number of different disciplines. So even if you don't pursue electromagnetics as your primary research area, either by combining them with other areas or making sure that you understand the material well enough that you can apply it when it comes into your future area of study, that is another way to succeed. And so how do you figure out which of these you would like to pursue, or if you want to avoid it completely? I mean, the first step is to take classes. That always helps. It gives you an idea of what the particular discipline involves and whether it's a good fit for you or not. But the other is to just gain experience working with things. So one of the things that I learned about and this can be either academic research labs or in internships or in industry. But one of the things that I really learned as an engineer was that you shouldn't count yourself short. Like having a strong background helps, but there is so much work that's needed beyond the initial brilliant idea and mapping of how to accomplish something. That there's plenty of work that you can do even with a basic level of experience, as long as you're willing to dig in and figure things out. So it's never too early, especially even at this stage, where you just have an introductory understanding, to really find labs and research groups and teams out there in industry where you can contribute and just get some firsthand experience to figure out whether you enjoy it or not. Kind of before I wrap up, I'll just go. We'll call this the unsolicited advice section. But looking back at my own studies and my own training and thinking about what mattered or what didn't, I feel like if I were to do my undergraduate again, I would focus on the following. So first of all, like, take classes, do well, but try not to do too well. Like, I would shoot for a 3.0 to 3.5 GPA for those in areas that if you're at an institution that works off of a 4.0 grade point average scale. But I think that, to me, the main mile markers are a 3.0 is where a lot of graduate school cutoffs are. So just making sure you at least get to that would make leaving grad school open as an option much more straightforward. And then 3.5 kind of puts you at the pretty good echelon. And if you can go higher than that, I think that's great, but don't put in the extra effort and over-engineer your grades like I did, unless you have the other things that people care about when you come out of your undergrad degree. Namely, try to get some actual hands-on experience, either by working with labs through professors that you're taking classes on, or finding internships in industry. If you can get a conference or a journal publication as an undergrad, that would be totally awesome and would set you apart from your competition. And then the third thing is just network and meet people. So try to collect business cards. Try to keep in touch with people that are having careers that you're interested, or working in organizations that you're interested in. But the main thing is focus on your evaluation criteria for your next chapter, not your current chapter. So looking back, I think that was something that I struggled with. Was I was really focused on how I was being evaluated today, and not on how I would be evaluated in the next stage, be it graduate school or my first job. And when you look at it through those lens, what people are looking for is not only the ability to perform well in classes, but the ability to work well with others, because almost all science now is big enough that you have to work in some kind of a team, but also, to be able to perform in their environment. If you're in a research environment, to be able to publish. If you're in the industry environment, then to be able to get real experience with as close as you can to real products and things that lead up to products. And so focus on that next step. You're going to be evaluated on not on your transcript, but on your resume. So keep an eye on your resume and use that as your guiding light as to how you make your choices of where you invest your time. Make sure that it's well-rounded, that the grades are good enough, but also that you have the experiences needed to show that you can perform at that next level. And finally, I also just want to say, you will belong. So one of the things that I did not see coming out of engineering is that I thought the only way to be a good engineer was by being a good engineer, by being smart, by being able to solve problems. But coming out, now that I've been out of school for a while and have worked on a number of projects as an engineer, I can tell you that out here in the wild, there are a lot of ways, a lot of roles that an engineer, just somebody with the title of engineer, needs to play in order for the organization to be successful. Sometimes that can be managing the project. Sometimes that can be evaluating an idea with feet set firmly in the reality of different financial or marketing constraints. And the other is just maybe just getting different personalities or different disciplines to be able to function effectively. So even though right now you're going through classes and your main form of being evaluated are exams and grades, and maybe that works well for you, maybe it doesn't, but just know that once you get out of school, as your career builds, all those other ways that engineers need to function and all those different roles that you need to play in order to be successful will become more and more important. And the different kind of skill sets that you need to have on a team to succeed is so varied that I'm confident that if you stick around long enough, you're going to find the role that you're good at, that suits your personality and that fits you. And so if you're succeeding now, great. If you're not, just hang in there, and the right role will be out there for you to discover. You just gotta keep at it. So with that, I'll just quit the yakking and wrap up this course. But I hope that during this process you gain an appreciation for the foundations and the general intuition that you need to pursue these other disciplines here. I encourage you to study more and learn more about these different disciplines, especially as a way to approach other topics. Like right now, as I'm recording this, machine learning is a hot topic, but as I've heard one researcher say, that as working in the area at the intersection of machine learning and physics, it's a lot easier to teach machine learning to a physicist than the other way around. So I think that even if this process is painful, I think that as long as you keep your eyes open and keep looking for opportunities, the understanding that you're building here, every experience that you have will help you. And keep your eyes peeled, keep searching, keep pushing, and I'm confident that you're going to find a place where you'll kick butt and do awesome.